Alrighty, so welcome to the third week of React Nights. I hope you enjoyed your homework. I've seen a lot of nice solutions, so hopefully it was interesting for you. If not, please let me know. I will make it interesting for you. Anyway, today we are going to move forward a bit. As I mentioned before in the introduction, we are going to build our app, right? And today we are actually going to start adding our products into cart. For those purposes, we probably will need some kind of global state management, and about that, Kostya will tell you more. So please welcome Kostya and enjoy.
Yeah, welcome guys. Very excited topic today. But before we get into global state management part, I just wanted to recap that's the stuff that we already know. So everybody already used something like this, right? Like this set state. And that is the way you work with local state in your component. And it's perfectly fine. It's very powerful. But the local state is confined only by the boundaries of your component. And sometimes this solution just doesn't work for larger applications. And to see what kind of problems we can have by using only local state, we can look at an example. So let's say we want to build a contact list application that looks something like this. So it has a top-level app component that has header and content component as its children, and then content has title and contact list component. Now, right now, the only component that has state is contact list, right? So it has an array of users, so it can render the list of users in the app. And that works perfectly fine. But let's say that we want to show the badge with the total number of users where it says all contacts, right? So we want to display the total number of users. And that creates the first problem. We cannot share state between sibling components, so we cannot pass it directly from contact list component to title component. And the way we solve it is by lifting state to the closest common parent, which is content in this case, and then we can pass it as props to the components below in the component tree. So that works pretty well, but let's say that instead of placing the badge in title component, we want to move it even higher in the hierarchy and have it in the info label component, which is under header. So in this case, we need to lift our state even higher to the closest common parent, which in this case is app, then pass it down to its child components, and from then we can pass it down to the component that actually needs the state. And you can see how it can quickly become a problem. Like even in this simple example where the component tree is very simple, we have just two components that need to have access to the state, but because of local state limitation, we have to have at least 5 components. And some of them, like header and content, they are purely layout-based components, so they should never know about the state and the users array. And when using a global state management solution, we can solve this problem by still having our state at the top level of our component tree, but instead of drilling down through all the parents, through all the child elements underneath, we can inject it directly into the components that actually need it. So that pretty much shows the problem that we can solve by using a global state management solution. So the question we should ask next is what should be in global state? Because it's a bad practice to put everything in global state, and for some things local state is perfectly fine. So to make a sound decision, we usually want to ask this question: should more than one component re-render if the state changes? So if the answer is yes, then probably the state should be global one. To make more concrete examples, I have a few suggestions as to what should be and shouldn't be put in global state. So usually you do want to put in global state information like session data, which may include the current user information and tokens. If you have the same data that has different representation in different components, like we've seen with the contact list example, where we display either a list of users or the badge with a number of users, but the source of data is the same, then it's also a good candidate to place in a global state. Also, for more advanced scenarios, it's the data that you want to cache or make available offline. It's not required that you put it in a global state, but by doing so, you can make your life much easier. On the contrast, there are some things that you should probably never put in global state, and those include things like local UI component state. Like if you have a drop-down element, you don't want to have its isOpen state to be in a global store, because obviously it's bound only to this specific component. You don't want to have loading states, so flags like isLoading, isCreating, isUpdating. They should also stay local. And another thing that you should never put in global state is form values. Usually you submit forms as one unit to the server, so it also makes sense to keep them local to the actual form. But it's also worth mentioning that sometimes, like these suggestions, they work in 99% of the cases, but sometimes there might be a scenario where you would want to have, let's say, form values in global state. But those are very rare, so generally you can follow these suggestions. Now, before we move to actual global state management solution, Redux and all that good stuff, there are some important concepts that we need to understand, because they're used very extensively in Redux and in all state management solutions overall. So the first one is immutability. So what is immutability? When we have an immutable variable, it's a variable that's, once it's been initialized, it cannot be changed. Well, this is like a technical definition. In JavaScript world, of course, we can change everything, so it should not be changed. It's our job as developers to make sure that we don't change the variables. And when we need to update the value, instead of mutating the original variable, we create a new one. So this is an example of doing things mutable and immutable way. So if we have an array of colors, if we call push method on array, it's going to mutate the original colors array. So we should not do that. Instead, we can create a new array by spreading items in the original array and then appending the elements. And I'm going to include more examples of doing things right and wrong way when it comes to immutability in the information to the lecture, but for now that's just an example to see it in action. So why do we want to have immutability? Well, the main reason, of course, is that it makes your code a lot more predictable, because you know that whichever values you pass through a chain of functions, you can be sure that none of those functions are going to mutate the values that you passed. Also, it is easier to centralize all the updates with this approach, and that's exactly what Redux is doing, but we'll get to it later. Also, immutable functions are easier to test, and it helps with render optimization. You may know already, or maybe not, but the way React works with state, whenever the state changes, if it has a reference to the old state and to new state, it can compare the objects, find only those properties that have changed, and then it updates the UI only for those properties that have changed. It doesn't have to re-render the entire DOM, so it makes rendering process very efficient. The second important concept that we need to cover, it's the idea of pure functions. So pure functions, it's just the regular JavaScript functions, but they follow a few rules. So the first rule is that a pure function, when it's given the same input, it always produces the same output. It never mutates the argument that it receives, and it has no side effects. To explain this more, if a function references a variable outside of its scope, if it calls an API, if it uses local storage, if it uses any sort of external resource, that is called a side effect, and that is a no-go for pure functions. So 3 simple principles. Does it make sense? Yeah? Okay, then let's see if it makes sense or you just agreeing with me. So I'm going to show you a few slides with the functions, and let's see if you can tell if those functions are pure or not. So what do you guys think about this one? Is it pure or not? No? No? Why not? Great, yes, it's called an API, so it's not pure. So what about this one? It takes like an array of to-do items, and then it filters out only those that aren't done. Is it pure or not?
From outside, it's getting data from outside, right?
Well, it takes, it only uses variables that the arguments that are passed to it, so it doesn't reference any external resources.
It's changing the arguments given, so it's impure.
Well, the thing is, filter function actually doesn't change the original array, it produces a new array. So this function satisfies all the 3 requirements, so this is a pure function. Basically, whenever you see map, filter, reduce functions, and use of like spread and destructuring operators, that is a pretty good indicator that you're doing something the right way, because those don't mutate original objects or arrays. So what about this one?
No, it doesn't give you same output for the same input.
Exactly, yeah, because it uses new date, which is not guaranteed to return the same value. It is actually guaranteed to return different ones. So it's impure. What about this one? No? Yeah, this one, it pushes to one of the arguments that it receives, so it changes the input arguments, therefore it's impure. And I have the last one that basically takes an array of numbers and returns the squared numbers. Is it pure or not? Yes, it is pure because it doesn't reference external resources, doesn't change arguments, and map doesn't mutate an array. Okay, this is good. So finally, we are ready to talk about Redux. So what is a Redux? A Redux, if you look at the documentation, it's a predictable state container. Basically, in our case, it's a solution to a global state management problem. And as I mentioned, there are other libraries out there that solve the same problem, but Redux is like way ahead of the game. It's the de facto standard, so if you go into work on real-world applications, you are bound to work with Redux. And so Redux is based on 3 main principles, which we are going to cover next. The first one is that state in Redux, state is a plain JavaScript object, so there are no magical data structures involved. It's just a plain JavaScript object. And it's a read-only, meaning that we should never mutate it. The second principle is that if we want to change the state, we dispatch an action. And action, it's just another plain JavaScript object that is required to have a property called type, which we call an action type. And that is just a unique string that identifies this action within your app, and this action type should be unique across all of your actions. It can also have some random payload data, and usually you want to include information that you're going to need to apply the transformation to your state. And the third principle is that this action eventually gets passed to a reducer. And reducer, it's a pure function, as we've talked about just now, that takes the current state of the application, it takes an action, and it's going to return the next state. Now, here you see a very typical structure that you're going to encounter in your reducers. So we basically have a switch case statement based on action type, and depending on the action type, we want to return the proper transformation of the state. And yeah, just to recap everything and put it in a full cycle, we have a view, which is our component that is subscribed to the global store, so it can get the data from the global state. If we need to change something in global state, we dispatch an action. This action gets passed to a reducer, which is a pure function. This reducer returns the next state, and this next state gets updated in a store, and store notifies all the views that are concerned about this particular piece of state. So that's the whole life cycle of Redux. Does it make sense so far? Yeah? No questions? Okay. All right, so then the next question that you should ask yourself when working with Redux is how you should design the shape of your state. So what do you want your global state to look like? And I have a few recommendations about this. And the first one is you want to keep it as flat as possible. So try to avoid multiple levels of nesting in your objects, because otherwise doing changing the state without mutating is going to get like really complicated. You also want to have a top level properties, as I call it, models. I think it's going to make more sense when I show the picture, but basically like if you think about application that we're building, we have products, which is one of the models. So probably you want to have, if you put products in the global state, you will want to have a property called models, which will be like an array of models. And we're also going to have items that we put into shopping cart. So the second top level property or model could be cart items. You also want to deduplicate or normalize data. Basically, if you have, let's say, an array of users, and then each user has, let's say, an array of posts, you want to extract those posts into a separate sort of model. And in users model, you want to reference them just by ID. So in general sense, you can think of your global state as a client-side database. So you pretty much do things like a relational style when you reference one model from another by ID. And this is the global state for the application we're going to build today. So this is the structure that I came up with. And basically we have a products property, which will be an array of all products. And cart items is going to be an object where each property will represent the product ID, and the value is going to be the quantity of this product purchased. So on the picture that you see on the screen, we have purchased 2 items of products with ID 1 and one item of product with ID 3. Okay, so we are about to get into the live coding part. So just wanted to recap the plan, what we're going to build right now. So we're going to define an actions and reducers for loading products, since right now we we just load the products from API, but we don't put it in global state. So we'll create an action for that. And we'll create actions and reducers for adding products to the cart. Then we'll put our global state on the top level component. So as you've seen on the pictures, the state still has to be somewhere on the top of the component tree. And then we'll see how we can inject store as props into components that actually need it. All right. Is the font size good enough, guys? Can you see it? Yeah? Dobrze? Yeah. All right, so there is some preparation work that I've done beforehand because like there is a lot of things that we need to do now. So I'm going to briefly cover all the things that I've done off screen, so to say. So first of all, I installed 2 new dependencies for Redux and React Redux. So one thing I haven't mentioned is that Redux, it's a framework agnostic library, so it can work with Angular, Vue, whatever. And if we want to use it in React application, we install React Redux bindings library. Then in addition to that, I updated the product component to include a button to add items to cart, which basically passes the product ID and the click event, and we'll see why we need both later in this demo. Then obviously there is a cart component, which is pretty simple. So it's going to receive an array of items from somewhere for now, and each item will have a product, and the second property is going to be quantity. So it's just going to render a list of products followed by number of items that we've purchased. So since we have a new component, we have a new route in the app.js file. So nothing new here as well. And the last change is that the layout component now is not just a wrapper, but it also has a header with 2 links, one to the homepage with all products and another one to cart. So the application looks something like this. There is add to cart button, there are 2 links. This obviously doesn't work because there are no items props yet, but yeah, this is the skeleton that we're going to use. So first of all, it's usually a good idea to organize all your global store related files in the same folder. So I'm going to create a new store folder, and then I'm going to create a new folder for each of our so-called models. So the first one is going to be called products, the second cart items. So for products, we're going to define the actions first. And to save us some time, nope, yes. Yeah, so this is the action we're going to need for loading our products. So it has a unique name, and it's a very common practice to name it in this way, like namespacing it by the name of the model followed by the action. And to dispatch this action, we'll have a load products function that will take an array of products and it will create a new action. So the action has a type, as we've talked before, and the payload. And then this will end up eventually in a products reducer. So let's create an index.js file for product reducer. So product reducer is also a very simple function. So it takes the current state and an action, and the default state is going to be just an empty array. Like right now, we don't need to do this switch case logic. We can just use action. We can just like return action payload. But since eventually we want to handle multiple actions, I'm still going to stick with this structure. So whenever we receive load products action, we're going to return simply the payload that we received. So we're going to replace an empty array with an array of products. Make sense? No? Okay. And we're going to do the same for cart items. First, we're going to define the actions. And yeah. So for cart items, we want to have an action to add product to the cart. So in our payload, we want to pass the product ID for the product that we actually want to save in a shopping cart. So again, it's very simple. So now we can create cart items reducer. Yeah, so cart items reducer follows the same structure as all reducers. So we take the action type, and if it's add product to cart type, we want to basically update the shape of our cart items property. So maybe it's a little hard to follow like this, but if we have our initial state is going to look like this. It's just an empty object, right? So when we pass a product ID, we're going to use the payload, which will have a product ID, so to create a key. And the value, we're going to either take the previous value from the state with this ID, and if it doesn't exist, we're going to turn it into 0, and then we're just going to increment it. So basically, if the property didn't exist, we set it to 1. If we try to add products with property 1 again, the state is going to look something like this. All right, so now we're done with the models. Now we can create the actual store. So I'm going to add index.js file in a store folder, and yes, I think I have it here. And it's going to look something like this. So another advantage of structuring your global state in a way where each top-level property is an individual model is that we can create these mini reducers for each separate top-level property, and then combine them together using combine reducer helper function from Redux package. Because otherwise, we would have to have like one large reducer function that would have to handle all the actions, and obviously, it would have to make sure that when we update like products property, that we don't accidentally override cart items property. So here we just import products and cart items reducers that we've just defined. Then we use combine reducers function from the Redux package to put them together into our top level root reducer. And then we call create store function from Redux package, passing it the reducer. And that's pretty much it. We have the fully configured store. So the next step is going to be we need to inject this store into the top level of our component tree. So to do that, I'm going to open app.js file, and we're going to import from React Redux package a special component called provider. Now we just need to wrap everything that we have here in a provider component. And the provider component requires only one property to be passed, which is the store. So we also need to import store from store and pass it over here. So now we have our global store available to all the components that will be nested inside of the provider component. Okay, so we're getting closer. Now we need to actually connect our cart component, because right now it expects props with an array of items that it never receives from anywhere. So to connect this component to global store, we're going to import another method from React Redux package called connect. And yeah, well, first of all, I'm going to rename this component to something different, like cart view, because we're going to call a connected version of this component cart. So down below we'll have const cart, and we're going to call connect function and pass it our cart view components. So now it doesn't really do anything because we are not specifying how we want to map props for our component from a global state. So the way we do it with Redux is that connect method expects a first argument to receive a function that is going to take the global state and transform it into a props object for our component. And we usually call it map state to props. It takes a global state, and we want to return an object. And before I forget, let me pass it over here. So this is the object that we return is going to match the props that the component receives. So we need to have an object with the property items. So I'm going to create an items property, and to set its values, we're going to access state cart items. But state cart items returns an object, as you remember, with this structure, right? But what we want to have in items array is that we have a property called product with an actual product here, and then we have want to have a property called quantity with an actual quantity. So we're going to, oh Jesus. So we're going to take the keys of this object, which is going to return an array of product IDs in cart item, and we're going to map it by taking it product ID, and we want to return an object that has a product, right, and a quantity. So the quantity we can get from the state cart items and use the product ID key to get the value, to get the number of items in the cart item for this product. And to get the product, we can now access state.products, which will return an array of products. And then we can just find a product where product ID equals product ID. So we're going to check the array of products, find the one that we need, and we're going to set it to product property. So now our cart component is fully connected. So if we go to the browser and go to my cart page, as you can see, it no longer breaks because it receives the items props, but since we haven't added any items to the cart yet, it doesn't show anything. Yeah, so then the next state would be to update our product list component to make it connected as well. So we're going to repeat the same procedure. We're going to import connect method from React Redux package. I'm going to rename this into products and create a new variable product list, which is a connected version of products. Now, since our products are going to be in global state, we don't want to have them in local state anymore. So I'm going to remove it from here. And when we map over a list of products, we want to get them not from state, but from the props. So we don't have these props yet, so I'm going to do the same map state to props function that is going to take a state, return an object with a key products. And now we don't need to do any data transformation. We can just call state.products. And we can pass it over here. Now, if we switch to the browser, we can see that it loaded something, but there is nothing on the screen. And the reason, because we actually loaded data from API, but we never put it in the global state. So to put it in global state, we want to dispatch our, what was it called? Load products action. And to make it available within the products component, we can define a second, we can pass a second argument to our connect method, which is going to contain our action creators. So the action creators is going to be an object, and of course we need to import from store products actions. We want to import load products action, and we can pass it over here. So what it does, it injects these action creators as props for this component as well. So not only can we access these .props.products, but now we can also access these props.load products. And this function expects an array of products, so we already have it from the API. So we're going to pass it down here. And if we go to the browser, looks like it's working, right? So it's loading data, it's showing the products. Great, so the last thing that we need to make is to make sure that we can add items to the cart. And to do that, we have another action creator that we can import from store cart items actions. And it's called add products. And we need to make sure to also pass it over here. So now, as I've shown you before, the product component has on add to cart property, which will receive a product ID and the click event when we click on add to cart button. So we can create a local function called handle add to cart, which is going to receive a product ID and the event. And let's leave it at that. And now we can set on add to cart property, and we can pass our handle add to cart function. Yes, it should be this handle add to cart. So the first thing that we want to do is we want to prevent default on the event. This is usually not a good idea, but in this case, we are required to do so because our whole cart is clickable. So whenever we click on Add to Cart button, the click event is going to propagate to the whole cart, and instead of adding to cart, it will trigger Go to Product Details action, and we want to avoid that. So first, we're going to prevent default the event, and after that, we can call Add Product Action Creator that we've injected over here, and pass it a product ID. Okay, I think it should be everything. So we load a list of products. Let's click once, twice on the first item and once on the second. This kind of sucks that there is no visual feedback, but we needed to make something like demonstrable within like half an hour, so it has to be enough. And now if we go to My Cart, you can see that the first product that we clicked on was added twice to the cart, then second was added once. If we go back to products again and click Add to Cart again, now we have 3 items. There is one more improvement that we can make and take advantage of our global state, because right now when we go to My Cart page and return to all products, it starts by loading products all over again from the API, even though the data already exists in the global state. So we can reduce the number of API requests by going to component did mount and using, and we can check if this props products equal, nope, length equals 0. So if we don't have any products, then we will load the products. Otherwise, we're just going to disable the loading indicator. And so it spins the first time we click on it, then we can add items to the cart, go see the cart. But now when we return to all products page, it doesn't load because it already knows that this data exists in a global state, so it doesn't have to call it again. And I think that's pretty much it for the demo. Do you have any questions about this? I know this is a lot, yeah?
Is there some mechanism within Redux which allows you to process actions and produce side effects?
Not within Redux itself, but you can use something called middlewares, and I'm pretty sure Honza Bartosz is going to talk about in the next part, so stay tuned. But yeah, like it's one of the shortcomings of Redux that you cannot use side effects just by using pure Redux. You need some additional solution. But again, I'll also mention a little bit about this later. Any more questions?
I have maybe a question
Yep.
about, I like the way that you can store all the data that you loaded to the global state.
Mm-hmm.
But maybe the users, or the question is, how do you handle the way that, for example, if a user is on the page for 1 hour and he doesn't actually like forces to re-render the page,
Mm-hmm.
so that he doesn't get the newest data, and maybe he doesn't even expect it because he doesn't know that this is handled by React, by JavaScript. He just uses the application.
Mhm.
It seems that routes are changing, so he would quite expect that he gets new data when he goes back. How do you handle this? Like, do you have some more advanced technique to do this there?
Mm-hmm.
It helps you to do this, or?
I see. Yeah, so like you don't have to do the thing that we did with checking the products and not loading again. I mean, it definitely depends on the use case. I mean, in some apps you want to have like new data as soon as possible, so you never kind of cache it this way. In some applications it's more appropriate, but then, for example, the better solution would be to still call the API, but for example, don't show the spinner, at least, so that users aren't confused. You just like update all the items that you have in the background. But again, yeah, it depends on the actual use case and what kind of experience you want for your users. Sure. Okay, then let's go back to the slides. So that was everything I wanted to talk about Redux. But it's also worth mentioning that Redux has a lot of bad light and bad press if you try to read about it online for a few very obvious reasons. So Redux, it's not ideal, it has its problems, and the biggest one is a ton of boilerplate. So like probably it was hard to see the boilerplate issue on a small example like this, but basically you end up writing a lot of repetitive code when you have to create the same reducers and the same action creators over and over again. Another issue is, as gentleman in the back mentioned, is that there is no way to deal with side effects by default in Redux, so you have to use like additional solution to make it work. However, there is a library that we are starting to use here in STRV, and it's gaining a lot of popularity, and it's called Rematch. So Rematch basically is a very thin abstraction layer on top of Redux, and its purpose to hide all the granularity and all the unnecessary details of Redux. So I have like an example here where we have a state which is a number, and then we want to increment or decrement it by a certain value. And like incrementing, decrementing a number seems like a very trivial operation, but that's the amount of code that we have to write to make it work, right? So we need our action types, our action creators, the reducer function with this ugly switch case statement. And Rematch, it basically does everything the same way, but behind the scenes. So, but you end up writing something a lot cleaner and more concise. So this is the example of the same code, but using Rematch. And again, I'm not going to talk about Rematch today, but if you're adventurous and you probably, maybe some of you already know Redux, I encourage you to read the documentation to see how it can simplify your life. And yeah, what this demo doesn't show is that there is also a built-in support for side effects, so you don't need to use additional library for the side effects. Anyway, that brings us to the end of my part. I have some resources for you to check out, which is basically the official Redux repository and Rematch repository. Redux also has a very thorough website where it explains all the concepts that we've covered today and the ones that we haven't in really great details. So if you have time, definitely go through the documentation. There's a lot of great material there. So to summarize what we've covered today, we talked about the state management problem, how the local state management differs from global state management. We talked about important principles such as immutability and pure functions, and we've seen a short demo of how we use Redux to solve the global state management problem. So now the homework. Well, you'll get access to everything I've done today, so you should not worry about like setting up everything from scratch. But what I want you to do is to create a new add to cart feature, but from product details page. So right now we do it from product details, from product list page. I want you to try to do the same from product details page. And the second part is to implement remove from cart feature, which will be like an additional button next to the cart item on a shopping cart page. Any questions about the homework? Anything else? Okay, then that's it for me, and thank you for listening. If you have any more questions, please shoot. We have, I think, 5 more minutes. Or we,
For someone
Yep.
who is learning this for the first time, like where does beginners usually struggle with Redux?
Well, from the projects that I've seen, people usually don't have problems understanding like how you work with the library, like all the technical details, but people struggle with the general concepts and realizing what should be or should not be in global state. So usually when people see Redux, they understand how it works and they start putting everything in global state, which is usually a bad idea because it makes your code more complicated. You create all these unnecessary structures. So that's why I took like more time to talk about the actual ideas and the thinking about like making a decision what should be local or what should be global. But other than that, probably that's the most common issue and the most common gripe is the boilerplate thing. Because yeah, as you start writing more and more action creators and reducers, you'll get sick of all the repetitiveness. But you have something to look forward to if you're a new guy. Yeah. That's it? Yeah? Bald guy?
Could you better connect the idea of immutability and pure functions to the whole Redux?
Okay. Yeah, basically, when your reducer is a pure function, so you should not change the arguments that you receive. You should not rely on any external resources in your reducers. And you should, well, basically return the same output when you're given the same input. And the same immutability idea goes into reducers as well, because when you apply a transformation to your state, or better say, when you create a new state, you don't want to change the original state because otherwise you're going to break everything. So that's why like immutability and purity are very crucial to the whole idea of Redux. Yes?
Do you use something to enforce it, like Immutable.js or something like that?
We actually discourage using of Immutable.js because it has like a bunch of issues. There are some other libraries that help you with the immutability part. We use extensively Ramda, which is more functional way to making immutable changes. Immer could be another good choice if you don't really want to worry about the functional parts and understanding how it works, because Immer kind of encapsulates all this immutable change logic. So you can do pretty much any transformation that you want, and Immer will take care for it. But yeah, Immutable.js, it's another solution, but it can be a little heavy. It can be a little hard to type when we get to TypeScript and typing part of the React Nights. So yeah, Ramda would be my #1 choice to recommend for anyone who wants to like try a library that helps with the immutable transformations. Okay, then I guess that's it for me. Thank you, guys.
So yeah, welcome everyone again. Welcome to second part of today's presentation. First, I will tell you how it's gonna work now. First half an hour, I will talk about Redux enhancers and other stuff around Redux, and second half an hour, I will be talking about the context API. Two good news. First, this presentation will be shorter, and second good news is that it will be full of live coding, so wish me luck with that. Thank you, Kostya, for introduction into Redux. and I will continue. So, short table of content. First, I will be talking about middlewares, then Redux DevTools, and then further reading and interesting middlewares and other stuff around Redux. So, when it comes to Redux, we already know about reducers, actions, store, how to bind actions, how to connect to store and get the data. But there are more when it comes to Redux, or when it comes to store management. In real world, we have to deal with another situation such as logging, crash reporting, handling async operations, I don't know, persist data, and so. And in order to do that, we need enhancers. And in Redux, we have middlewares. So, what the middleware is? Middleware is a piece of code that we can put between receiving request and response in Redux. A middleware has access to store, current action, and result of next action. It's great for filtering requests. I mentioned logging, and also handling async operation and whatever you can imagine. One important thing I would like to point out is that we can compose as many middlewares as we want, basically, but we have to be aware of the thing that amount of middlewares expand complexity. So you don't have to involve many middlewares if you don't need them. So yeah, so now I start with some live coding. So how to involve a middleware, or rather start with the middleware itself, how it looks like. So middleware is function that returns function. So in the end of a middleware, we should send a result further. So just call return next.action. I will explain you what those variables mean later. So this is middleware, and how to implement it into our store. We will import another component from Redux. It's called apply middleware. And apply middleware is a function that we pass to our create store initialization. And now we just put our middleware into. So just console log for check whether it works or not. Yeah, here it works. And as I mentioned, we can create as many middlewares as we wish. So I can create another one, add some middleware number 2, and works works number 2, and involve it or include it into our apply middleware. So now we can see that it works, and it works too. And yeah, so it works. So what these variables are? First, store is reference to our Redux store. So we can use functions based on documentation on store object. So for example, we can use store get state to get current state. So now, as we can see, we have empty cart items and empty products. And it's interesting because we already have a products. Reason for that is because we called next in the end, and when we console logged this, we hadn't fetched them. So we can save result of next action to variable, and in the end return result. And now, when we call store get state, we should have a in the store we already have a products. Okay. So next is function that send basically handling further to next middleware level. And action is actually current action. Yeah, as you can see here, we dispatched products /load with payload, as you've seen our previous lesson. Yeah. So what's further? So okay, this is a general interface, and next is how to connect it into store. And now let's create some logging, meaningful logging middleware. So let's just log current action. So console.group, and let's get a type. So let's group our logging into group end. Where is that? Yeah. So now we have our console log group with action. Then what we can log in? We can take a look at current state. Store get state. So current state. So now we can see current state. Then we call the next to get access to next state. Just console.log next state. So store get state. So yeah, we have our logging middleware. And once I click to add to cart, I can see another action. So current state before clicking was empty cart items. Then I can see ID of the product and count. So okay, this is logging middleware, and it's actually how it works. So yeah, and you can use middlewares for things you wish. For example, managing async requests. It's very common to use Tang if you have a simple case. Tang is actually dealing usually with fetching data. Where is that? Yeah. Damn, it's too long. Never mind. There's another one, Redux Persist, that helps you with storing your data in local storage, for example, in order to avoid, I don't know, repetitive fetching or going offline. Another one I haven't used, but it seemed interesting as well. It's Redux Bacon. It's for handling Google Analytics. So you can try it if you want. Yeah. You should be aware of another thing, that you can also use middlewares for example, crash reporting. It's very common to send error to third-party service, and it takes some time usually. You should be aware of the thing that until one middleware is done, handling is not moved to another one. So sometimes it might take some time. So okay. Let's move further. To DevTools. So the logging is fine. It works, but sometimes we need even more. This is still basically still simple logging, and we have actually a common tool for dealing with operations in Redux. It's extension for browsers. I have it over here, and it's called Redux DevTools. And here you can see more advanced information or more verbose information. Here you can inspect action that happened, and on the right side you can see what's happening with the action. So now I can see that products slash load has been dispatched, and I can see type of the action and payload. Here I can check the state itself, like a whole state. So it's not quite complicated. It's not huge, but still handy. And another interesting thing is diff. I can check a diff once I do any action. This is handy to check what happened. Once I step to another action, I can see that the states are equal because we didn't fetch products again. So state is same and action is same. Once I click to add to cart, I can see that I send a payload and type again, and diff is also here, and I can see basically what we implemented within our previous logging middleware. You can test it somehow, but to be honest, I've never tried that. Trace I didn't use as well. So yeah, this is Redux DevTools. What do we have next? Yeah. So we went through middlewares, DevTools, and I also added some useful middlewares. I'm not gonna talk about them because it might be complicated, and my colleagues will be talking about them later. But you can check them if you want. First one is actually recipes. So you can check in official documentation how to deal with situations. So first one is async actions. Is pretty common. Where is the fetching? Yeah. This is the most important part. Just dispatch action to fetch posts, and the action basically doesn't return a regular action object, but it returns another function that manage all the fetching functionality. And this is pattern for the mentioned Tank middleware. So this is very handy, and we will use some patterns from that later. Another interesting part is reducing boilerplate, because when your application and when your store starts growing up, you also be repeating your actions and reducers, so you can reduce it by generalization of actions and so. But I'm pretty sure that our colleagues will be providing this information later. This is just for fun. Normalizing state shape, it's also for bigger stores, not for ours yet, because sometimes you have like database-like data. So for example, here you can see that we have blog posts, comments, and inside of each comment we have information about author, and it starts to be complicated to get the data. So it's good practice to normalize them and just reference ID of comment, for example, or ID of an author. So check it out if you are interested. Yeah, and another one is working with React Router, because sometimes you need to work with the router inside of reducers or inside of your containers, and so this is another good part. Okay, so and your homework will be quite easy, and it's actually implement Redux DevTools into your projects and into your browser. Well, and that should be it. Do you have questions?
What are the steps in action processing? Does it go through middlewares first and then to reducers, or vice versa?
Yeah, first middlewares, and then I hope I'm right, but then go to reducers. Yeah, because you can actually leverage actions and payloads of actions in the middlewares.
How can I synchronize state between many devices or instances of application?
Mm-hmm. Well, it's a quite tricky question. You can do it. You need something like WebSockets or something, and well, you can, when somewhere an action happens, you can send something to your server and synchronize with other devices, for example. That might be a solution. Okay, another question.
How was all this done before Redux, like this middleware and stuff? Was it like so complicated that that's why they come up with it?
You know, do you mean before when we managed data with state, for example?
No, I meant the enhancers,
Mm-hmm.
the things that you introduced.
I guess it came with needs to dealing with those situations. I've seen many examples when people were dealing with something, some side effects inside of reducers, but as Kostya mentioned, it's anti-pattern, so I'm not sure, but I think it came with release of Redux itself. And middlewares are not something what came with Redux. We know middlewares from Node Express and other frameworks. It's common pattern actually. So it might didn't come with needs. It just as a general part of requests and responses pattern, I guess. So if you don't have any other questions, I would like to move further. And I would like to move to Context API. So, Context API. I would like to point out the problem of props drilling again. And Kostya, I have stolen your picture, so I hope you don't mind. It's actually a pretty nice picture. So, props drilling issue. What it means? It means that we have source of data, and usually it's on some top level. So for example, here we have our source of users on very top level in app. And in order to get data into component-free tree deeper, we have to drill the props through every single level. Even though components such as header or content or title actually doesn't pass data, but it doesn't matter. Basically, we have to pass the props through all levels we need to get to components they need the data. So it looks like when it comes to code, it looks like this. This is our very top level. Can you see it? I hope you do. This is our very top level component or container, and in a local state we have a list of users, and users are needed only by contact and info label components. So we have to pass down this list of users through some attribute. So we pass the users into header, and header doesn't care about it and just pass it down further to info label through another user's attribute. Also, content doesn't care about it as well, just pass it down to contact, and contact and info label use them. Basically, we already solved it by Redux, but sometimes we don't have Redux, or our application is quite small, and Redux might be quite verbose or quite huge. And last but not least, it's another additional dependency that we might not need. So context has been with us, or with us in React from the beginnings, I guess. It's another built-in tool for data management. It doesn't require to pass data as a props through all levels of components. This is the props drilling
go through middlewares first and then
issue.
users, or vice versa?
And usually it's used for global data as users, as events, products, team. But it's difference between one difference between Redux and context is that it's suitable for local-oriented data as well. So, Context API, React since version 16 brings provider consumer pattern. Provider requires initial data passed as a value attribute. Default value. When you are creating context, default value is used when a parent provider is not present, and it's useful for testing. Consumer uses the render props pattern. You can check it out what it means here. And good thing with this pattern is that it allows us to consume multiple contexts. We have another way to bind context. It's via context type. You can access the reference in any lifecycle or render method, but cons is that you can use only one context in same time, which means within one container. So this is how we bind the provider and how we create a context. So let's start again with live coding. So first, I will create a products context. So just import React. And create a context. So React.create context. And now we pass default values. So in our context, there will be a list of products. So I will just export it. And I also export provider and consumer. I don't have to do that, but I just do that. So products provider. So products context.provider and products consumer dot consumer. So yeah, you can see same thing here, and now we have to implement a provider into our app. So I will open up product list. X. It's okay. I will import our context. Actually, I will import the provider. And I just wrap output of render function into provider. And now I have to pass value. And value will be product. Here in componented mode lifecycle method, I basically got rid of Redux stuff. I just fetch products and put it into state. And in render, I put it down into products provider. And it should work. Seems it works. Yeah. And now consumer. I have a product. Yeah, well, I basically get rid of this map function. Should be nothing, just loader. And I will create another container, products list.js. And I don't have to pass anything, I just import our consumer. Products consumer. And as I mentioned, consumer uses render props pattern, which basically means that instead of passing JSX children, we as a children use function. And as a parameter of function is a context. So we have products context. I just console log it. Yeah. I need to import it. So now it works and it logged products. So we didn't have to pass products as we are props drilling. And it's object, so we can just so it works. And I guess I can use product here. No, it works with bad styling, but it works. It's yeah. Yeah, but it works. I don't know why.
You
It's
should wrap it inside of return.
Maybe there are two unloaded lists. No.
yeah, maybe. Thank you. Yeah, thank you. Another good thing is that we can use multiple contexts. So for example, here I have config context with some config information, and user context is just an example, but I can use it like this. Second way how to define context is here via context type. Advantage of this way is that we can, as I mentioned, we can get a context data in our lifecycle method or render method, but disadvantage is that we can use only one context type within one container, basically. We can combine it somehow, but it's not handy, and well, don't use it. Yeah, this has been Product Car demo, and context versus Redux. Important thing is that in context we cannot use middlewares. So this is big disadvantage. Scaling of data structures and operations. I mentioned that at the beginning. Context is suitable for simpler apps, simple data structures, and simple operations. For example, I say cannot cooperate between contexts by some handy way. We are not able to handling side effects, and that's it. I wanted to mention something, just forgot. So, summary. Context is tool for managing data. Fixes problem with props drilling. It's suitable for simple apps without advanced needs. And we can use it when we don't have Redux or when we don't libraries such Redux or MobX or another systems. But as I mentioned before, it's for simple cases. We can use both Redux and context together, but based on different purposes, I would say. Yeah, and don't support middlewares, handling side effects, and other advanced features. Here's a link to doc, and that's it. If you have questions, go on.
You said you can combine those context and Redux
Mm.
in a project. Is it a common practice or not?
I wouldn't say it's common, but since you don't, since you are not required to use context only for global data, you can use it wherever you want. So you can just, there might be some container, and inside of a container there might be some, I don't know, third, fourth level. There might be component that needs the data from the container, just local data, and you can use context for that as well. So this is like combination, I mean. But I wouldn't definitely store data of your app on two places. This is anti-pattern.
In practice, if you had like a small project and you would be using Context API, so maybe to follow up on my question, how would you apply middleware or something like that? Like another
Yeah.
library or Express or?
Well, let me think for a couple of seconds. There's no chance to apply middlewares as we know them. We just can do something in a top level component, some handling, I don't know. There might be a function to add product to cart, and you can implement it with some logging. When you click the button, you can log something and then update state of the cart somehow. But as I mentioned, it doesn't scale. So any other questions? Okay, if you don't have them, so thank you for your attention, and it's all. No. I didn't want to mention that at the beginning, but reason is that we use Redux, and we are not gonna use context in our app anymore. So there's no reason to give you homework. You can play with it if you want, but yeah, that's what I thought. Yeah. Thank you.
So guys, before you leave, small info from my side. As always, you can find some information on a week free on our Slack, so please check it out. Second thing, we are going to upload some stuff over there, I would say pretty soon. The only thing we need to do some kind of reviews and so on. Anyway, it will be there soon, I promise. And the last part, we probably noticed there is a new guy doing the recording, so we are going to have like super nice recordings pretty soon. Hopefully Ondra will do it like ASAP, right? Actually, it's his homework for tonight. So I hope he will do it like just fine. And regarding your homework, actually, I believe this one is going to be pretty tricky, so don't feel like, be afraid again. Approach your mentors and just discuss all this stuff. State management could be tricky, but it's actually super simple. You will understand it pretty soon. Anyways, thank you for attending and see you next week. Thanks. Great.